Hey everyone, as promised, here is a YouTube video where I go over some of the homework problems. All right, I'll just scroll through quickly so you see which ones. So I'm going to do 2, 7, 8, 10, and 11. All right, so if you feel good about a bunch of these, skip through to the ones that are more relevant for you. If we start off with number 2, we have 2 times quantity x plus 2 equals 2x plus 4. We're going to simplify the left-hand side of the equation and get 2x plus 4 equals 2x plus 4. Now we have a true statement, right? The expression on the left is the same as the expression on the right. Regardless of what number you plug in, that will always be true. So we conclude that we have all real numbers. You probably saw in middle school maybe infinite solutions. I'm going to say for this type of problem, I would like to see all real numbers as our answer. All right, once we talk about number sets, that will make a little bit more sense. The symbol here is a double barred R. Okay, so you put the 2 lines and then you draw the R like I just did. And that is our answer. You can either write all real numbers or the symbol. The symbol will come up again later on. So it's good to learn that now. But either one is fine. For number seven here, before I do anything, I do want to flag that I have an x or really any variable in the denominator. And we talked about this in a class. If if a variable is in the denominator, right, when I check my work, I'm going to plug whatever I get for whatever value I get for x into the equation. And so in this case, if x were to be equal to 0, I can't do 2 divided by 0 or 3 divided by 0 because it will be undefined. So before I actually do any work, I just want to write to myself that x cannot equal 0. Because again, if x were to be 0, when I plug it back in to the equation, I'll get something that's undefined. So before I do any work, eliminate one or however many options you can. Now we want to find the LCM. And the LCM is a little bit more interesting here because, again, we have x in the denominator. We also have a 2 in the denominator. But to find the LCM, we're just going to multiply them together. If you're trying to add fractions together, right, like 1/3 plus 1/4, your teacher probably told you in middle school, when in doubt, just multiply the 2 denominators together to get the LCM. And it's the same thing here. The reason for that is because the only common factor they have is 1. Okay, so we're going to multiply by 2x on both sides. And I am going to write this step out so it's as clear as it can be. So 2x times 1/2 minus 2x times 2 over x is equal to 3 over x times 2x. And you know that when we multiply by 2x, we're really multiplying by 2x over 1. All right. And now we have a 2 in the numerator and a 2 in the denominator. And so we can cancel those out. And then x times 1 is just x. And then we have an x in the numerator and an x in the denominator. And 2 times 2 is 4, right? We can bring down that negative. And then here we have an x in the denominator and an x in the numerator. So we can cancel those out. So 2 times 3 is going to get me 6. And I'm going to get x is equal to 10 when I add 4 to both sides. Before I box my answer, I do just need to make sure that it's not the number that I eliminated. Of course, 10 is not equal to 0. So that is, in fact, our answer. All right. Again, that intermediate step where I canceled out all the x's, as you get more confident, you can probably do that in your head, but I just wanted to show you where that was coming from. If we look at number 8, this is similar to one we talked about in class. So again, goal is to clear our denominators. So we got to find the LCM of 2, 5, and 4. That is, of course, 20. All right. So when I multiply by 20, again, I'm going to write out this step just so we see it. So I'm going to do 20 times x minus 2 over 2 minus x minus 1. Oh, I got to write the 20. Minus 20 times x minus 1 over 5. And then, of course, 1/4 of 20 is 5. And so the takeaway here is that instead of doing 20 times x minus 2, I'm going to do 20 divided by 2. And I'm going to get 10 times the quantity x minus 2. And then 20 divided by 5 is going to get me 4. I bring down the negative, and that's equal to 5. So the step that I wrote here, right? I think as we get more confident, that step you can do in your head. This step, however, is the one that I want you to write down. And the reason for that is that if you don't write this down, if you try to do it all in your head, a lot of you, most of you, almost all of you, will forget to distribute the negative 4 to the negative 1. You'll just do 4 times negative 1 and get negative 4 instead of doing negative 4 times negative 1 and getting positive. Like I said, I gave this to my sophomores, very similar problem. And the first time they see it, they just about all make that mistake. So this is the step you want to write down. And we're going to get 10x minus 20 minus 4x plus 4, right? Negative 4 times negative 1. And then I'm going to combine like terms. So 6x minus 16 equals 5. I'm going to add 16 to both sides. 6x is 21. So x is going to be 21 over 6. I said improper fractions are great, but we're not done yet, right? We need to make sure they're in simplest form. So 3 divides 21 and 6. So I get 7 halves. If you want to write that as 3.5, you're welcome to. But 7 halves is the answer as an improper fraction. Again, the takeaway here is you want to write down the step that I boxed so you don't forget. So you make sure that you distribute the negative. All right. Let's talk about number 10. Number 10 is similar, except for we have these coefficients going on in the numerator. So there's 2 ways to do this. I would say maybe the easier way is just to distribute in the numerator. So I'm going to get 3 minus 6x over 2 minus 5x minus 15. That's all over 6, and that's 10x minus 50 all over 3. All right. And now the problem looks very, very similar to the previous problem. So the LCM here is 6. I'm going to do 6 divided by 2, and I'm going to get 3. So I'm going to do 3 times 3 minus 6x. And then 6 divided by 6 is just 1. So that'll be minus 5x minus 15. And then 6 divided by 3 is 2. So I'll get 10x minus 50. All right. And again, that's the step that you want to write down. So you remember to distribute correctly. So I do 9 minus 18x. And this negative here, right, is just like a negative 1. So we're going to distribute negative 1 times 5x is going to be negative 5x. Negative 1 times negative 15 is positive 15. Not sure what number I was writing there. And then 20x minus 100. All right. So now what's going to happen is before I start moving things around, simplify the left-hand expression, and you're going to get 24 minus 13x is equal to 20x minus 100. And so, sorry, minus 23x. There was a mistake there. Minus 23x. And I decided to try to keep the x's positive, so I added 23x to both sides, and then I added 100 to both sides. So I get, let's see, I get 124 is equal to 43x. So I'm just going to divide by 43 on both sides of the equation. And I'm going to get that 124 all over 43 is equal to x. And before I box my answer, I do just want to check, as it looks a little weird, but yes, 124 over 43 is in fact the answer. Okay. Oftentimes, guys, especially freshmen year, see a fraction and they freak out. It's okay to get fractions. All right. The only way we get more confident with them is by working with them more often. All right. So 124 over 43 is the answer. No need to convert it to a mixed number. All right. And then the last one here, again, it looks a little bit different because we have x minus 3 in the denominator, but we're going to do the same approach. We have an x in the denominator, so we need to pause and ask ourselves what value x cannot be. If I plugged in 3 here, right, 3 minus 3 would be 0. The denominator can't be 0. So I'm going to flag that x cannot be 3. Okay. The LCM is actually just x minus 3, right? It's the only term in the denominator. So I'm going to multiply by x minus 3 on both the left and on the right. And so I'll write this down one more time just so we see it for the first time. So x minus 3 over 1 times 6 over x minus 3 minus 5 times x minus 3. And that's going to equal, I'm going to move this over a little bit, equals 2x over x minus 3 times x minus 3 over 1. So again, the x minus 3's cancel. I get 6, and then minus 5x plus 3. And then over here, the x minus 3's cancel. So I get 2x. So I'm going to get 9. 15. So I'm going to get 21 minus 5x is equal to 2x. I'm going to add 5x to both sides, so 21 equals 7x. And so the answer I get is that 3 is equal to x. But like I said, before you box your answer, you should go back and look. And we said in the beginning that x could not equal 3. And I'll just show you that quickly, right? So if we try to check our work, we'll get 6 over 3 minus 3. Minus 5 is 2 times 3 over 3 minus 3. So 6 over 0 minus 5 is equal to 6 over 0. And we can't divide by 0. We say that it's undefined. So what this is known here as an extraneous solution. So basically what happened here is that x equals 3 is a solution to this equation, to this equation, to this equation, but it's not a solution to the original equation. Okay, that's what I mean when I say it's an extraneous solution. So we solved it. We got one solution. Turns out it's not the solution. So we're going to put a big X through this, and we're going to conclude that we have no solutions. All right. So the last, that's very similar to the second to last question from the homework packet, and we'll pick up with that in our next class. All right, but I just wanted you guys to try this, work with something like x minus 3 in the denominator, and turns out that there are no solutions. So again, we'll talk more about that in class, our next class. But hopefully you appreciate the video. Like I said, if you need more help, come see me in the MRC before the quiz. Thank you guys for watching, and I will see you in class soon. Thanks so much. Bye.